In this video, we're going to look at counting techniques, combinatorics, it might be referred to in some places as well. So we want to be able to explain the difference between combination, permutation, and some other counting techniques, calculate problems involving counting techniques, and use factorial, permutation, and combination on your calculator. So first of all, just kind of differentiating some different ways of counting. So this first question says, in how many ways can we choose 3 letters from the letters A, B, C, and D if letters cannot be repeated? One thing to kind of keep in mind is that when we just see this word here, in how many ways can we choose, that usually implies that the order does not matter. So here for A, you can see we could choose ABC, ABD, ACD, or BCD. So ABC is the same as ACB or BAC in this case, because remember, we're just choosing the letters. So in this case, we end up with 4 different ways. How many ways can we choose and order 3 letters from the letters A, B, C, D if letters cannot be repeated? So obviously order matters now. So here you can kind of see we took this first one, A, B, C, and then we did all of the possible combination of those 3 letters. So just rearranging the order of those 3 letters. And then we took A, B, D here, and we did all of the possible combinations of rearranging those 3 letters. And then we have A, C, D here, and then we did all the possible combinations of those letters. And then we had the B, C, D, and we did all the possible combinations of those letters. So when I have 3 letters, there are 6 different ways that we can rearrange those. So in this case, then we come up with 24 different ways that we can order or choose and order 3 letters from the 4 that we were given. C, how many ways can we choose and order 3 letters from ABC? So notice now we only have 3 letters to choose from. So we're going to choose and order those 3 letters, but now this time the letters can be repeated. So in this case, you can see all of the combinations. So we start with A, and then we've got the combinations where I have 2 A's, and then combinations with 2 B's, 2 C's, and then the combinations involving no repeated letters, but involving A. And then over here, you can see we start with all 3 B's, and then we've got different combinations here, and then we've got all 3 C's, and then some different combinations here. So if you look at this, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 in each column here, and we've got 3 columns. So in this case, we're going to end up with 27 different options. If you think about it, there are 3 letters to choose from, and we were going to make that choice 3 times, which is 3 to the 3rd power, which is 27. Over here, we had 4 letters to choose from, and we were choosing and ordering those, so 3 times. So here, the first letter, there was 4 letters for me to pick from, and then after I picked that letter, I couldn't repeat it, so then there were 3 letters for me to pick one. And then after I've chosen that one, then there's only 2 left to choose from, and then I was only choosing 3. It's 24, so you can kind of see where those 2 numbers are coming from. All right, finally, how many ways can we choose and order any number of letters from A, B, C, D if the letters cannot be repeated and order does not matter? So really what we're looking at here in D is what we refer to as subsets. So this is all the possible subsets of A, B, C, and D, including single letter choices, the empty set, and then choosing all letters. So we could choose 1 letter, we could choose 2 of the 4 letters, we could choose 3 of the 4 letters, we can choose all 4 letters, or we can choose nothing. So if you look at how many options we have here, we've got 4 ways to choose 1 letter, we've got 6 ways to choose 2 different letters, we've got 4 ways to choose 3 different letters, and then we've got 1 way to choose 1 and 1 way to choose none of them. So this gives me 10, 14, 15, 16. So I've got 16 different ways that can happen. Okay, so looking at a little bit of terminology here. A subset is a selection of objects from the set, and this can include choosing none of them, which remember we were going to refer to as the empty set, choosing any combination, so any number of items up to and including all of them. So when we're talking about subsets, we could be talking about choosing none of them, 1, 2, 3, all the way up to and including choosing all of them. Factorial is the product of a number and all consecutive positive integers less than that. We have notation for factorial, so it's a number followed by an exclamation point. And this means we take n times n minus 1, n minus 2, etc. until we get down to 1. So the product of a number and all consecutive positive integers less than that number. So we keep counting down until we get to 1, because 1 is the first positive integer. So here, an example would be maybe 3 factorial is 3 times 2 times 1. So that would give me 6. Or we could go 4 factorial is 4 times 3 times 2 times 1. So 12 times 2 is 24 times 1 is 24. Permutation is an ordered arrangement of a number of objects from a given set. There's notation for permutation. It's a subscript of n, a capital P, and then a subscript of r, where n is the number of items I'm choosing from, and r is the number of items we're choosing. The formula for NPR is n factorial over n minus r factorial. So a combination is choosing a number of objects from a given set without regard to order. So again, we have some notation here. It's subscript n, capital C, and then subscript r. Again, n is the number of items we're choosing from, and r is the number of items that we're choosing. Our formula for NCR is very similar, n factorial over n minus r factorial times r factorial. All right, so taking a look here, we've got some just general formulas. Most of these formulas are just different versions of the first formula, which is called the general multiplication rule. So if we're trying to find the total number of ways that we can choose from a number of different sets. So this is choosing one item from several different sets. So you've seen these questions before a lot of times, like on your standardized testing. A person is choosing from 4 different pair of pants and 5 different shirts. How many outfits can you make? So you just take 4 times 5 and get 20. So you have to be choosing one item from several different sets. So then the multiplication rule when objects can be repeated. So if I can repeatedly choose the same object, so maybe like you're doing a multiple choice test, or you're rolling dice, or you're selecting numbers for like the lottery or something where you can repeat your digits, then so the key here is about repeating. Then we're going to do n to the k. N is the number of items we're choosing from, and then k is the number of times we're choosing. So then we have the permutation rule when ordering all objects from a set of objects, n objects. So this would be if we have maybe a group of people and we're going to line them up in a particular order. So we're going to take all of the people in the group and put them 1, 2, 3, 4, 5, 6, 7, 8, etc. So then this is just n factorial, and again is just the number of items that we're choosing from. Then you have this permutation rule when ordering r objects from a set of n objects. So this would be that we're not using all items. So this would be maybe a situation where you are having an election and you're going to have a president, vice president, secretary, and treasurer. Maybe 10 people are running, but only 4 of those people are going to win those positions. And then those positions are unique, and they have an order. So this is that NPR, and that's the formula that we looked at before. Then we have the permutation rule when ordering r objects from a set of n objects, and some of them are identical. So this oftentimes will come into play. It'll be like, here's a word, and how many ways can we rearrange these letters so that maybe a letter repeats itself. So if there's some repetition in the items that you're choosing from, then you're going to use this n factorial over n sub 1 factorial, n sub 2 factorial. So n is your total objects, and then n1 is the number of same objects, and 2 is again your number of different same objects. Then we have 2 sort of situations where we're talking about combinations. So the combination rule, remember combination means the order doesn't matter when we're choosing r objects from a set of n objects. So then this is the NCR. So again, n is my total number of objects that I'm choosing from, and r is the number of times that I'm choosing. And then we have the combination rule when selecting any number of items. So remember, this is 0 items to the total number. Then we just use 2 to the n. And the reason that we're doing that is that you can think of it this way. Basically, for every object in the set, you're saying, should I include this or not include this? So it's yes or no. So there are 2 ways to make the decision for each object, and you're going to make that decision for every object in the set. So when you're doing a counting question, I would kind of go through these questions in my head. So once you look at the situation, ask yourself, do I have several different sets or only one set? So if you're choosing one item from several different sets, then you're just going to use this multiplication counting rule. If you're not, then the next thing you want to ask yourself is, can I repeat my selection. So if you can repeat, then you're going to use this formula here. If you can't repeat, then the next thing you want to think about is permutation versus combination. So does the order matter? If the order matters, then you're doing permutation, so you have to choose one of these decisions. And then if order does not matter, then you're doing combination. And then it's just, am I selecting a given number or am I selecting anything from 0 to the total? So let's look at some examples and see how this will work for us. So how many ways can you order the letters of the word dragonfly? So do I have different sets or do I have one set? Well, I only have one set, which is this set here of these letters. So we only have one set. So then the next thing we have to ask is, can I repeat? So once I put the D in a particular location, can I put that same letter somewhere else? No. So we cannot repeat. Does the order matter? Obviously the order matters because they're telling us to order them. So order matters. Yes. So then this tells me that I'm doing a permutation. So when I'm doing a permutation, then we have to say, am I using all of the letters in this group or I'm only choosing some of them? So this tells me how many ways can I order the letters of the word dragonfly. So that would tell me that I'm going to use all of them. So I'm going to come back here. So I'm doing a permutation and I'm using all of my objects. So it's just n factorial. So I'm just going to go n factorial here. So how many letters do I have here? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I can just go 9 factorial. So here in your calculator, you have this factorial option in here. So you just type the 9 and then press your math button, go over to the probability menu, and then number 4 is your factorial. So 9 factorial, and then we've got our answer. So 362,880. Now I also want to point out with this question, we could have used the NPR permutation when ordering R objects from a set of N objects and just included N and R to be the same value. So if we say N equals 9 here, we have 9 items to choose from. R is 9 because I'm going to choose all 9 of them. Then I would have 9P9. Again, this NPR is in your calculator. So we come back here, you're going to type in the 9. And then we're going to go to math and over to that probability menu again, and then we're going to choose the NPR. And then we have to type in the second subscript, which is 9 again, and then you can see we got the same answer. So there's really no preference on which way you do it, especially given that both functions are in your calculator. All right, so let's look at this second question here. So we've got 16 actors answer a casting call to try out for the different roles. Notice it says different roles, so that's key. As dwarfs in the production of Snow White and the Seven Dwarfs. And how many different ways can the actor or the director cast the 7 different roles? So here, again, remember, go through your questions. So is there more than one set to choose from? No, we just have this set of actors. We have 16 actors. So there's only one set. So then remember, my next question is, can I repeat? So once I cast a particular in one role, can I cast that person in a different role? No, so no repetition. So then remember, my next question is, does order matter? And in this case, what we have to think about is, since they're different roles, then there is order. Not necessarily that it's 1, 2, 3, but the first actor is going to play Sleepy, and then the second actor is going to play Grumpy, and so there's order to that. So if they're different situations, then the order matters. So order matters. So then remember, once order matters, I know that I'm doing a permutation. So then the next question we ask with permutation is, am I choosing all of the objects? So I have 16 and I'm only choosing 7, so we're not using all. So then we're going to have to do that NPR. So N, remember, here is going to be 16 because I have 16 to choose from, and R is going to be 7. So we're going to have 16P7. So again, remember, this is in your calculator. Then we've got our answer of 57,657,600. All right, our next question here. A national hamburger chain has 8 toppings for its burger. How many different ways are there to have a burger prepared? So is there more than one set to choose from? No, we just have one set of toppings, so there's only one set. Can I repeat? So once I put tomatoes on my burger, am I going to put tomatoes on there again? So we're going to say no to that, so no repeating. I know that you might be thinking some people might order like double cheese, but unless they tell you you can do that, you should assume that that's not possible. Does order matter? So does it matter when you're getting your burger if you say tomato, cheese, and pickles, or if you say pickles, tomatoes, cheese? No, they're going to make the same burger for you. So order does not matter. So remember, if order does not matter, then we're doing a combination. So if you remember with combinations, once I make that decision that I'm doing a combination, we just have to decide, am I choosing a given set of R objects, or am I choosing any number of objects? So here we could choose nothing. We could just get a plain burger, or we could get everything on our burger, or we could just get one thing, or we could get a combination of 2 or 3 or 4, etc. So here we're doing subsets because we can choose any number of items. So if we're doing subsets, remember that's 2 to the n. In this case, we have 8 toppings, so that's going to be 2 to the 8th. So we got 256 different ways that we could order the burger. All right, so in this next question, we have the Miss America pageant. 51 contestants must be narrowed down to 10 finalists who will compete on national television. And how many ways can the 10 finalists be chosen? So we only have one set. We have the 51 contestants, so we just have one set. Once I choose a person, I cannot choose that same person again, so no repeating. Does order matter? No, because we're just choosing the 10 finalists who will compete on national television. So you don't care if you're chosen first, second, third, fourth, you just want to be in that 10. So order does not matter. So if order doesn't matter, remember that tells me that I'm doing combination. And then if I'm doing combination again, I have to say, am I just choosing a certain number, or can I choose any number of items? So here we know specifically that we're choosing 10. So I'm just choosing a certain number of items. So we're going to do the NCR. So then N here is that I'm choosing from 51, and R is that I'm choosing 10. So this is going to be 51, choose 10. Just like the NPR, the NCR is in your calculator. So we're going to type in the 51, go to your math button, over to probability. We're going to go down to number 3 option, which is NCR. And then we're going to type in the second subscript, which is the 10. Then we have our answer here, which is 1.278 times 10 to the 10th. So remember what this really means is 1, 2, and then 1. So I have to move that decimal point 10 places. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 places here. So then I have to add that 0 on the end, and then I'm going to move that all the way over here. I would accept either one of these options on the test, but you should be careful in MathXL how they are asking for the answer. All right, so in this next question, how many ways can we order the letters of the word bumblebee? So again, let's go through our questions. Bumblebee is just one set, so there's only one set to choose from. Can I repeat letters? So once I put the U in a particular place, can I put that U in another particular place? And the answer is no. So no repeating. Does the order matter? Yes, because it tells us. So order matters. So remember, when order matters, that tells me that I'm doing a permutation. So once I'm doing a permutation, we need to figure out, is it am I using all the items, or am I just using some of the items, and then are there any items that repeat? So notice here you've got 3 B's, you've got 3 E's, so we've got repeating letters here. So we are doing permutation. But we have identical items. So then remember, we're going to use n factorial over n sub 1 factorial, n sub 2 factorial, etc. So here we're going to do this. So how many total letters do I have here? So 1, 2, 3, 4, 5, 6, 7, 8, 9. So n equals 9. And then n sub 1. So n sub 1 we're going to say are B's, and there are 3 of them. And then n sub 2 is the letter U, and there's only 1. And then n sub 3 is the letter M, and there's only 1. And then n sub 4 is the letter L, and there's only 1. And then n sub 5 is E, and there's 3 of them. So then I've got 3, 4, 5, 6, 7, 8, 9. So all 9 letters are accounted for, and then we can just go ahead and plug that into our formula. So we're going to go 9 factorial over 3 factorial times 1 factorial times 1 factorial times 1 factorial times 3 factorial. Now really the 1 factorial is just 1, so you can really kind of ignore it. You can just go 3 factorial or 9 factorial over 3 factorial times 3 factorial. So now you just want to be careful putting this into your calculator. Either this needs to go in parentheses, or you need to put that into your fraction notation. So in the calculator we can go 9 factorial divided by, and then do parentheses, 3 factorial times the 3 factorial again. Or again, remember, you can use your fraction notation And we can do 9 factorial over 3 factorial times 3 factorial. And we end up with 10,080 ways that we can do that. All right, here we have Tennessee license plates consist of 3 letters of the alphabet followed by 3 numerical digits. Digits go 0 through 9, so there are 10 of them. Find the number of different license plates that could be formed if no restriction on the letters or digits can be used. So this no restriction implies that we can repeat. So this question is kind of a combination of 2 things. So we have these license plate, and it is 3 letters followed by 3 digits. So really we have to kind of divide this into 2 problems here. So how many ways can I choose these letters, and how many ways can I choose the digits? And then I have to put those together. So when I said we have to choose the letters and the digits, so this is and here. And anytime you say and when you're trying to do a counting problem, that means to multiply. So we're going to figure out the letters. How many ways can I choose the letters? We're going to figure out the digits. How many ways can I choose the digits? And then we're going to multiply those 2 together. So here for the letters, we're going to say, okay, so with the letters, there's only one set of letters. There are 26 letters in the alphabet. So there are 26 letters to choose from. I can repeat. So remember, if we can repeat, then when we can repeat, this is n to the k. So this would be 26 to the third, because I'm going to choose 3 different letters. Or you can think of it this way. I'm going to 26 ways to choose the first one, 26 ways to choose the second one, 26 ways to choose the third one, which would be the same as 26 to the third. So over here with the digits, we're going to do the same thing. There are 10 digits to choose from, and I'm going to make that choice 3 times because we can repeat. So this would just be 10 to the third again. So then we can go to the calculator, and we're going to do 26 to the third times 10 to the third. And we get 17,576,000. All right, on this one, we have 18 seniors, 12 juniors, 10 sophomores, and 7 freshmen in the math club. If one member from each grade level is to be selected randomly for a competition, how many different groups can be chosen? So this is an example of having several different sets. We have the seniors, the juniors, the sophomores, the freshmen, and we're going to choose one from each of those. So we do have different sets, and we're choosing one from each. So we have different sets and we're choosing one from each. If you're choosing more than one from each, then it becomes a different problem where you have to kind of break it down a little bit. So as long as you're choosing one from each group, then you're just using that multiplication counting rule. And so remember here, we're just going to take the 18 times the 12 times the 10 times the 7. And then we just get 15,120.